Okay, so this is going to be a video on the P-series and simple harmonic series. So we're going to start off with a definition of what a P-series is. Very simply put, the P-series is an infinite series of this form right here, where I have the summation of 1 to infinity of 1 over n to the P power. So it looks just like that right there. P is a positive number. Okay? So the first thing you want to be able to do is, can you tell me if something can be in this form? Because just because it's however they look at it, you want to make sure that you can put it into this format to know that you have a P-series. So let's take a look at some examples that I have over here and try and determine if these are going to be P-series or not. Okay? So the first one here is A. Can I put that in a P-series form? Well, the first thing is, look at the exponent. It's negative, which means that gives you the fraction that you're looking for. So that means this right here can be written as the summation k equals 1 to infinity of 1 over k to the 0.8. And so then the question is that a P-series? Well, yeah, it is. Okay, this is a positive number. That's all it had to be, is positive. So yes, it is. And your P is 0.8. And that's going to be important for our future convergence or divergence choices. Let's take a look at B. Okay, again, it has a negative exponent, so we can rewrite this one, 1 to infinity, and this will be 1 over 2 to the n power. So this right here is not a P-series, because in the P-series, the unknown, or the change, is the base number. Okay, so this is fixed, so this is not a P-series, this is a geometric series. This is geometric. Okay, let's take a look at C. Can I do that one? Notice this one right here starts at 10. Okay, this number right here does not have to start at 1. It can start at any positive integer and it's still fine. So this right here would be the summation k equals 10 to infinity 1 over k to the 4th. And so then yes, this satisfies that, and P is equal to 4. This one's pretty obvious there. Can't make, it's not a fraction. This is a quadratic. This is a simple no. Okay. What about this one? Well, yes, it's already in the proper format and all that stuff. So then, yes, this is a P-series, and P is equal to 1. Okay. So that's the first part we have to do, is be able to determine if I even have a P-series form. And so that's what you want to look for as you're doing this, okay? So then the next part of our questions are this. Let's talk about the convergence and divergence of a P-series. So the P-series that we just got done talking about will converge if the P number is bigger than 1. So if that number there is bigger than 1, then I know this series is going to converge. And it will diverge if that number is between 0 and 1. If it's equal to 1, like in this example right here, then you have what's called the simple harmonic series. Okay? Or harmonic series. And this right here, because it's equal to 1, this right here is going to diverge. Okay? So we're looking for P numbers that are bigger than 1, then I know that this series right here is going to converge. Okay, so let's look at some examples and see if we can determine that. So the first thing you want to do in this examples here is you want to make sure it's in the proper form. You want to put it in the P-series form, which means you want to have 1 over k to a power. So rewrite this in power form, and you'll get the summation k equals 1 to infinity 1 over k to the 3/4. So this is a P-series, and P is equal to 3 over 4, okay, which is less than 1. Okay, so this series right here will diverge. Okay, let's take a look at this one right here. Here we have this, n equals 2 to infinity. Rewrite this as 1 over n to the pi over 3. Okay, And so what is pi over 3? Well, pi is 3.14 divided by 3, so that's going to be a number bigger than 1. So here our p, this is indeed a p series, and our p is equal to pi over 3, which is greater than 1. So this series will converge. Okay? This one's a little bit more tricky. Okay? Even though it doesn't look like it was, and you think, well, maybe I can't put it in that format, a little bit of creativity goes a long way. Here it says 1 minus pi. Well, I can get the fraction if I can make this exponent negative, and I can do that and show it's negative by factoring out a negative 1. So if I factor out the negative 1, now this exponent is negative, which now I can then write it into 1 over k to the pi minus 1. So this is a p series where p is equal to pi minus 1, and pi minus 1 is greater than 1, so this series will converge. Okay? And so then, again, at the bottom over here, they're going to see this a lot on the AP exam. When p is 1, the p series is called a harmonic series, and the harmonic series diverges. You're going to use that quite a bit. Make sure you understand that, okay? So that's the p series. It's pretty quick and pretty simple. Get it in the proper form and determine if p is greater than 1, or for convergence, less than 1 or equal to 1, and it will diverge. If you have any questions, let me know.